Hello and welcome to this presentation entitled Magic Telescope Data done by the group For the Horde. Members of this group consisted of Josiah Maharaj, Keelan McLean, Rabi Mahabir, and your presenter for this presentation, Jerome St. Louis. The study of high-energy gamma particles is done by the usage of imaging atmospheric Cherenkov telescopes, IACTs. These ground-based telescopes study gamma-ray photons at very high energies. The major atmospheric gamma-ray imaging Cherenkov telescopes, or MAGIC telescopes, are a pair of gamma-ray telescopes comprising of a single measuring system. MAGIC detects short blue Cherenkov light flashes that are produced when neutral gamma rays enter the Earth's atmosphere. The atmosphere is opaque to gamma rays, which allows the IACT to observe a byproduct of electromagnetic cascades initiated in the atmosphere by very energetic gamma rays, namely the Cherenkov light. The light is focused into the telescope, and analysis of the image forms allow the characterization of the primary particle and determination of the energy's content and incoming direction. There are two events that can be detected. One of them is a gamma ray shower. The other is the hadronic shower, also known as background noise. The issue lies in differentiating between these two events, as there is a large degree of similarity between both events. In order to differentiate between the two, simple statistical methods were used as well as machine learning. The steps in differentiating between both events involve data cleaning, followed by data statistical analysis, and finally, data processing using machine learning. The first step that was taken was data cleaning. However, since the data had already been pre-cleaned, there was no need for this step. The next step taken was to perform simple statistical analysis on the data. The attribute information involves taking measurements based on visual significant information about the data. Therefore, the best method of achieving this would be figuring out an appropriate representation scheme, applying it, and performing manual or automated inspection of the represented data. However, no appropriate visualization scheme could be determined to represent the data. Hence, statistical data was calculated using the dataset to find the first-order moments, minimum and maximum values, column means and row means, as well as the covariations. Finally, machine learning was applied to the dataset. It was deduced that classifications and clustering were best suited for this problem, and as a result, they were used. Under classification, the decision tree classification method, KNN classification, as well as the naive Bayes classification were used. To cluster the dataset, K-mean clustering was applied to the dataset. In order to perform any other prior methods, the data first needed to be split into a test dataset and a trained dataset. Both sets were randomly selected from the dataset, and the training dataset was then used to test the test dataset. To accomplish both the statistical analysis as well as machine learning methods, the dataset was imported into RStudio, and the programming language R was used to analyze the dataset. Most of the data were represented in the form of tables, with the exception of the decision tree classification method and the K-mean clustering method, as both had associated visuals to accompany it. The results of the statistical analysis are shown. The maximum and minimum data was found along with the skewness and kurtosis. The column means are also shown here. Lastly, the covariations are shown here. This was done in order to help visualize the data. A simple decision tree of the dataset is shown here. This decision tree was used to analyze the dataset as it looked at all parameters in the dataset in order to classify the signal event as either a gamma shower or a hadronic shower. The accuracy of the decision tree method, KNN method, and naive Bayes method were found to be 0.79, 0.792, and 0.26 respectively. Finally, the following table and diagram were created using the K-mean clustering method. The minimum and maximum values measured show the minimum and maximum observed energies of the telescope, regardless of whether the specific energy observation belonged to a hadron shower or a gamma signal. The values observed, however, have no significant meaning of their own, but show the range of the signal values in the dataset. The means of which row and column in the data has no significant impact of the analysis of the data. The columns simply represent constituents of the energies of each of the events measured by the telescope. As the energy-based events have to be visually examined, the energies may in fact represent positional variables. This means that for each row, the column values may have little statistical correlation, and the physical phenomena itself, the measurement of the high-energy particles using a ground-based telescope, gives no implication of meaning of relationship between rows. The row means have been more significant in determining the class. This is due to the fact that the classification accuracies of each method were relatively high. This is also possible due to the fact that the dataset used is a simulated dataset, and hence the number of gamma readings are overestimated. Regardless, the high classification accuracy suggests that there is a relationship between each parameter in deducing its class. As for clustering, it was shown that 15% of the total observations classified as gamma in the original dataset were placed into one group, and 85% of the gamma observations were placed into group 2. Likewise, for the hadronic observations, 29% of the total hadronic readings were placed into group 1 and 71% were placed into group 2. As the clustering diagram indicates, there is no clear visual separation between the clusters. This is due to the fact that both events are very similar as previously stated. In conclusion, differentiating between gamma events and hadronic events is a very difficult task, given that both events are quite similar. However, the results indicate that there exists a relationship between the parameters and its class for a particular reading. Hence, further work is required with more advanced techniques in order to deduce the relationship. Lastly, we would like to thank Mr. Azam Abdul for the support and guidance in completing this project. Thank you.